Hi, grade 9s. We're going to go over some nutrition again today and the nutrients that we need for our body. So this is going to continue from what we did last week and then go a little bit deeper. So we're going to add in this week some mystery and intrigue by adding in why is the mayor of Pleasantville sick. So we're going to be looking at the town of Pleasantville over the rest of the unit, and we're going to use it kind of as an investigative strategy. So what we're going to be covering in this section is, again, what are nutrients, and then talking about the main differences between organic and inorganic, and then the four main types of nutrients, the carbohydrates, the fats, the proteins, which we talked about last week, and then adding in vitamins, talking again about micronutrients and macronutrients, and then optimum amounts, which we started talking about last week, and then talking about how we take nutrients into our body. So we talked a little bit last week about ingestion, digestion, and absorption. Today we're going to add in osmosis, diffusion, and active transportation, as well as talking about substrates. So our new elected mayor in Pleasantville, Mr. Hamilton Berger, you can call him Ham for short, has not been feeling well lately, and his wife, Sally Salmonberger, you call herself for short, suggests that we go to see a nutritionist to help figure out what's going on. She doesn't think that the mayor eats very healthy, very common for wives to think their husbands don't eat very healthy, and she wants to find out what's going on and if there's a better reason, like just in nutrition, that can help him feel better. So the mayor goes to see the nutritionist, Dr. Eaton Wright, and he gives Mr. Hamburger an informal pamphlet to read over to find out more about nutrition. So first of all, the essential substances that are necessary for humans are we find in our environment. They're necessary for growth and survival. They are essential. Nutrients are things that you can't make in your body and you have to get from your food. So examples would be big compounds such as glucose, which we get from our plants with photosynthesis, small compounds such as table salt, and then pure elements such as nitrogen, which we actually just breathe in. So all of those are very important for our survival. In any nutrient, you're going to have a chemical substance that the body needs to survive and provides energy or raw materials. So the organic nutrients contain carbon and inorganic nutrients do not. Now, this is a little bit of a trick because you can have inorganic nutrients that contain carbon, but they don't contain chains of carbon. For example, carbon dioxide is not an organic substance, because there's just one carbon. You need to have chains of carbon, which are found in your carbohydrates, your fats, your proteins, your vitamins, and your fiber. So, organic nutrients. They're essential for life. Chains, like I just said, chains of carbon. And living things, organic compounds, are more abundant than inorganic ones. So we have more carbohydrates, fats, proteins, and vitamins in our body than we have our inorganic. So this is an example. So you can just have a look here on your own when you're just looking at the PowerPoint to sort of remind yourself what the difference between carbohydrates, proteins, and fats are when you're eating them. So some things obviously fall in between, but we're looking at keeping a balanced diet for our macronutrients. So when we're looking at this, you've got the carbohydrates. Carbohydrates provide energy through respiration. So plants do photosynthesis, animals do respiration, cellular respiration, and which is the opposite process. We can use simple sugars in our carbohydrates, such as starch, and our plants produce the carbohydrates, and the animals get them from the plants, of course, with us eating them after they've done photosynthesis. The fats themselves can be made in the body. They store energy from unused carbohydrates, and they also can help protect our skin. So they provide our oils or our waxes that keep our skin moist. We can eat them and then break them down into carbohydrates for energy later, which is why they're considered to be the stored energy of our body. Proteins provide the most structure of cells and tissues. They were required for growth, repair, and repair of tissue, not transpiration. They are a major component of enzymes, which cause the natural reactions in our body to occur quicker. So they're super important. And then vitamins are also catalysts for important chemical reactions. Remember, catalysts speed up chemical reactions, and they can be coenzyme factors, which means that your enzyme needs them to have the reaction. And they're often found in similar amounts to the other organic nutrients. So the reason why they were left out last week is because they aren't always considered a macronutrient. They're often considered a micronutrient. So our inorganic nutrients, they do not contain chains of carbon. They occur naturally in the environment, like water, carbon dioxide, and our salt, which is sodium chloride. And we can create inorganic compounds, like plants can create oxygen, humans create carbon dioxide, and we actually can create hydrochloric acid in our stomachs for digestion. They also include our minerals, like our calcium, our magnesium, our iron, our potassium, all those things that you guys did last week in our inorganic assignment. So this image is kind of a neat one to look at, and I would recommend you take some time when my face isn't sitting in front of it for you guys to look at this and just go through the PowerPoint, because it talks about what you need, what vitamins and minerals are needed for different functions. So for example, for your brain and for your memory, you need vitamin B and folic acid. For digestion, vitamin A, vitamin B, C, and D, and it gives you some types of foods that help with keeping those functions safe and healthy and where you want them to be. Like bone strength, we all know that we need calcium for strong teeth and bones. I'm sure you guys have heard that when you were younger. I certainly did. But also things like garlic is good for your heart and your blood because it contains omega-3s. So these things are interesting, and we need to know kind of what we need to eat to keep ourselves healthy. So with macronutrients, we tend to say macronutrients are our fats, our lipids, and fats and lipids are the same. Our fats or lipids, our carbohydrates, and our proteins. But there's also 6 main macronutrients, which are kind of more of our inorganics. So oxygen, carbon, hydrogen, nitrogen, calcium, and phosphorus. So we also need these in larger amounts than anything else. So oxygen we need for our respiration, for our breathing. We use that to turn sugar into energy for our bodies, which is our respiration. And it takes up 65% of our body. So it's a pretty large percentage. Carbon is the building blocks for all organic matter. We use them for carbohydrates, lipids, proteins, nucleic acids, which is in our DNA, and our vitamins. It's 18% of our body. Hydrogen, we use in almost every single molecule in our body. It makes up 10% of our body's mass. And considering that hydrogen is the lightest of all of the elements on the periodic table and takes up 10% of our mass, shows how much of it we carry in our body. Nitrogen we need for growth and repair of cells and tissues, and it's a major component of all of our proteins. It's about 3% in our body by mass. Calcium is important for building bones and teeth, but it also helps your nerves and muscles function properly. It's about 1.5% of your body's mass, which surprises me because I feel like we have a lot of bones. Our phosphorus is important along with the calcium in building our bones and our teeth. You can't make DNA without phosphorus, so it's very important, and it's also used for cell division. Inheritance, so like our genetics, our DNA passing down of molecules, cannot happen without phosphorus. It's about 1% of our mass. So again, this is another image that you can look at on your own, which shows how much we have in our body of each one. Okay, so our micronutrients are trace elements we only need in small amounts. So if we have too much of these, we can actually negatively impact our health. This is what you guys did in your assignment last week. So it's kind of that Goldilocks syndrome where you can have too much, you can have too little, or you have the right amount. And so the right amount is super important for our body. So here again is an example given of selenium. And this is required for proper enzyme functioning, but too much can cause birth defects, which is not what you'd necessarily expect when it comes to trace elements. So some of these can have disastrous effects in ways that we don't always see, which is why we've done all of this testing now. So how do you know how much is enough? So as I just said, there is this optimal amount for proper growth and maintenance and reproduction of all living things. So you need to know where that is. That has to do with having a balanced diet. So you can have many different kinds of food, eating them in like good amounts, and then you will know that you kind of don't have too much, you don't have too little, you have that Goldilocks principle happening. Now some of our micronutrients, if you have too much of them, your body just gets rid of them naturally and you don't have to worry about it. But others you have to be a little bit more careful of. So all of these things are important when it comes to your daily diet. So Meyer Burger, does now know so much about nutrition that he starts to get really excited about it and he wants to learn even more. He went to the Pleasantville Library and started reading more information about nutrients. So I've attached an article here if you're interested about 5 diseases that nutrition can help prevent. Plants, how do they get their nutrients? So this is more like how we get our nutrients now. So plants get their nutrients by absorbing them either through the soil, through osmosis, diffusion, or active transport. So we need, like, plants can't walk around, they don't have mouths, they can't eat them, so they have to get them through other methods. So diffusion is when you have chemicals going from a high concentration to a low concentration. It is passive. It doesn't take any energy for this to happen. It's just molecules hitting each other, and they start out in a really tightly compact area and spread throughout the room. We see this happen in our daily lives all the time. It happens when someone makes popcorn in the kitchen and you're in the basement and all of a sudden you can smell it. Popcorn's my favorite snack. So I always know when popcorn's being made. But it's diffusion of the smell or the scent particles of the popcorn spreading all over the house. There's also, in classrooms, I always used to get really annoyed when people would spray like Axe body spray. I hate Axe body spray. And they would spray that in one corner of the room thinking I wouldn't notice, but of course diffusion let my nose know right away that that had been sprayed, and it's diffusion of the particles across the room. So they didn't say, hey, Axe body spray, go over to Miss Young, we know she hates it. No, it just happens naturally. It happens throughout the world, and it happens in lots of different ways. So when you have diffusion in your plants, you're going to have low concentrations of the nutrients that you want inside the roots of the plants, and you'd have a high concentration outside in the soil, and they would then be absorbed into the roots of the plants. Osmosis is very similar to diffusion, and you will actually spend a lot more time on osmosis when it comes to grade 10, and I think you also did it in grade 8, talking about movement of water. So when you have osmosis is diffusion, so it goes from a high concentration to a low concentration. It takes no energy, it's a passive process, but it has to travel, it has to be water, and it has to travel through a membrane. So osmosis is diffusion of water through a membrane. And again, this happens when the soil has water in it, and it's being able to take it into the roots and spread it up to the rest of the plants. Now, active transport is a different one. Active transport is when you actually take some energy and you are going to actively move your chemical from an area of low concentration to an area of high concentration. So when we need a lot of nutrients, we are going to take energy from our body and we are going to pull those nutrients in, even from areas of low concentration. So the fact that we go from a low to a high requires energy, and we use that as ATP. You don't need to know in grade 9 what ATP is. Animals eat, digest, and absorb all the different nutrients that we need, and we talked about this a little bit last week. So we ingest it by taking it into our mouths. We digest it by either chewing, breaking it up, or even having it broken up by some of the acids in our stomach, and then chemical digestion, which is breaking it down into small enough molecules that we can absorb. And for that, we definitely use our stomach acid, but we also use enzymes. We also then need to absorb those nutrients across the membrane. And when we absorb our nutrients, we're going to absorb those throughout our small intestine and our large intestine. So again, this is just a little bit more information, and because I thought these pictures were so cute. So they obtain their nutrients for normal growth from the air we breathe and the food that we eat for all animals, and we take food into our bodies through ingestion, and then it goes next to our digestion. These pictures are not as cute because it's digestion and it's inside our stomachs. So digestion breaks things down into smaller particles. We also use hydrolysis in this case, where we have water to help us break down our food. So you can actually excrete water, and when you're excreting the water to help you digest, it can make you actually feel really thirsty after you eat something like a chocolate bar. So the reason why you feel thirsty afterwards is because you've actually used that water in your body to help break down the chocolate bar. Okay, sorry, and the next one is animals absorb. So the absorption occurs when these small particles go into the blood. So we need to get them into the blood somehow, and for that to happen, we're going to absorb them through our small and large intestine, and once it gets into the bloodstream, they exchange through the capillaries. So the blood carries them throughout the body, where they're either stored or where they're used right away. You don't have to, in grade 9, know the smaller processes of where the absorption necessarily occurs, but you do need to know that absorption is how the nutrients get into the bloodstream. So last but not least for this video is going to be talking about substrates. So substrates is where an organism lives or moves. So as you can see in these lovely pictures of mold, mold grows on bread. So you need to have the bread to have the mold. Also, pink snow, which apparently smells like watermelons. I have not seen this before. Please don't do this because it's very, very dangerous for you. But there's an algae that contains chlorophyll in the pink. And it actually will live on snow, turn it pink. It gives off kind of a weird smell, which is why people sometimes ingest it. But it's like super toxic for you. Now, snow mold happens every year, and actually I'm allergic to some snow mold, so in the spring when the snow melts, sometimes I get, it's like a cold, it's not very sick, but it's like an allergy to the mold in the air that comes from the melting of the snow, because all of that mold then has grown on top of the snow and is released back into the environment. So very interesting. Also, another example of an organism being attached is a sea anemone, which attaches itself to the rock so that it doesn't fly through the water. So those are the substrates, and that should get us through nutrients.